Oh, hello everybody. Michael Jenkins here for the second session for Diploma Materials and Methods. Now, first up, haven't had many inquiries yet in regards to assessments, so I hope all of you have had a look at those assessments and things are certainly making sense. It's something that we do have to obviously get looking at very quickly if you haven't already. So if you do have a look and you do have any queries, please let me know as soon as possible. Now, beyond that, so I've put up a video last week for consultants and authorities in regards to basically the constraints around building that come, or the legal constraints around building. This session is about design considerations. So I'll try to go through this fairly quickly. Now that there are design consideration notes here for you for at home, I'll just bring up the slides now and get them happening. So I'll try to be going through this relatively quickly because this is not, as I said, it provides the background to what we do with materials and methods, and it certainly dictates a lot of what we build and why we choose to build in certain forms. But you're not essentially assessed on this. So this is background information. Now, just in this first slide, yeah. So there's a few fairly iconic buildings. So South Australian architect Max Pritchard. His work here on this one, and this is a fairly well-known property down on the Great Ocean Road. So some interesting sites that and interesting architectural projects that will dictate what materials and designs are chosen. So what really drives an initial design? Well, not all design is site responsive, but I'd venture to say that good design starts by being site responsive, and with that site we've got several things to look at. So what is the size of the block, the shape of the block, slope and gradients, rivers and creeks flowing through, retaining walls and structures. So on that last point, retaining walls and certainly retaining walls can be quite expensive, and also the movement of soil and the dumping of soil can be difficult and problematic at times. So there may be other design solutions rather than a form of construction that relies solely on retaining walls. For example, you can build a house with an elevated floor, pick it up off the ground, get it onto some adjustable piers, and then you can sail over some interesting topography without needing to do too much groundwork or retaining walls. Certainly rivers and creeks flowing through. Well, the initial thing, if I see a river or creek close by to a development, and we're on a septic system, the first thing to think about is where you can do septic soakage in relation to that creek. The SA Health guidelines in regards to on-site wastewater systems dictate that you can't have any septic soakage within 50 metres of a designated watercourse or a borehole. So to find those designated watercourses and or boreholes, you can get all of that information on the SA Map Viewer, which is a state government geographic information service that links all of the geographic information from the various different departments onto a free information service, much like Google Earth, but has a host of layers in there. Slopes and gradients, certainly will dictate what ends up being built on a site. I think I'd like to add to this section as well in terms of the nature of the soil underneath. So expansive clays will also dictate what can be built on a site. So expansive clay, there's certainly ways to deal with particularly reactive soils, but they're quite expensive, and often a site responsive choice can save you a lot of money in that matter. Also, bottom left hand picture here, we've got a bush setting. As soon as you see a bush setting like that, obviously CFS is a consideration. So CFS have to gain access. They will dictate that you have to clear typically a minimum 20 metres, but typically 30 metres around a house site for that house, and then that conflicts. Well, then you have your obligations under what is it? It's the Native Vegetation Act to pay for reinstatement of those trees elsewhere. So to offset the loss of native vegetation, you have to contribute towards the planting of native trees elsewhere, which can be an expensive procedure. So site configurations, factors that affect construction costs. So earthworks, retaining walls, as mentioned before, both of those can be quite expensive. Piers as well. So piers are where you use an auger, or typically you use an auger, and dig down through the soil to create a circular, basically a circular post in the ground, which you fill with concrete and reinforcing mesh. Other forms of piers, so as we can see on this house here, down the bottom here, we've got a little cursor there moving around. They look like timber piers, but typically used today are steel piers, so 50 by 50 RHS with an adjustable top for bearing the load of the building and picking it up off the ground to create that suspended floor. Also, underpinning of existing structures and or neighbouring structures. So certainly when you've got neighbouring construction, it's quite a consideration to think of how that building will be affected, or if it will be affected, and if you think it's likely that a building will be affected nearby, it's very important to get a dilapidation report in place. That's a report that covers the current state of that building and any building defects, so that if there is a dispute that arises around any damage to that building during the construction, it's easily clarified as to what extent that building was damaged prior, or did it have any pre-existing conditions. So those dilapidation reports, they can be prepared by an external consultant. So site location, site and lot number. Avoid building on the wrong lot. Sounds like a no-brainer, but it does happen from time to time, or certainly preliminary works start happening prior to discovery of these things. Every saleable portion of land has its own separate certificate of title, which shows on that certificate of title the registered proprietor, so who owns the property. A very good thing to check if somebody engages you to do work, ensure they are the registered proprietor of that property. Description of the land. So that description of the land is about providing a legal description. So that description talks about where the boundaries are, how large the land is, what form of interest there is in the property. So the main type of interest is fee simple. However, you also have leasehold interests and things like moiety title. They're quite rare, but you may in your profession come across a thing called a moiety title, or a strata title, or more commonly community title. So these are different forms of title, different forms of what we term interest in a property. Easements are essentially another form of interest in a property. So it's typically an easement takes in a portion of the land, and the use of that portion is controlled to enable typically services to be run. So under a power line, you've got typically a 6 metre wide easement that restricts any building work to happen underneath that power line, or on top of drainage services and sewer services. You typically have an easement as well to ensure that nothing is built on top that would restrict access to servicing that infrastructure. You can also have easements for things such as access to other properties, access to other facilities such as water, and then at times various other easements that relate to either adjoining properties or infrastructure. An easement is what comes under the umbrella of what is known as an encumbrance. So an encumbrance is what encumbers the use of anything. So let's say I would like to have complete control of what I do with a certain allotment. I can only do that if there are no encumbrances lodged on the title. So one form is an easement. So that easement is lodged on the title. It stops me from building on a portion. Whereas an encumbrance, so other forms of encumbrance may be a developer's encumbrance. So when there are large developments that happen, large broadacre sites are carved up for creating housing developments, typically you'll have a developer's encumbrance imposed on every title that will place some restrictions on what materials are used for building the houses, and also stipulate things such as you'll need to have a garden established within 12 months of building the house, just so that the people who buy into that development have confidence there will be a certain aesthetic and a certain form of design, homogeneity that will be achieved by that development. So, and then other encumbrances, liens, it's where you've got a financial debt against the property, or a mortgage registered against the property, or possibly even a caveat. A caveat is where somebody else stops you from transacting that land. A typical form or typical reason that would cause a caveat to be lodged is where somebody does some building work on a property, and then the owner decides not to pay the builder. The builder can then apply through the courts to have a caveat lodged upon that title to stop anybody transacting that title. Certainly if you are engaged in doing some design work and you look at the title and there's a caveat lodged on there, that's a very big red flag as to you want to gain clarification as to what the nature of that caveat is, and the nature of the events that led to the installing of the caveat on the title, because it may be indication as to whether you get paid in the future. With the certificate of title, you have an attached survey plan image, shows boundaries and angles and lot number, and then location of easements. So basically it's a plan that shows all the geographic information, the visual information for the title. Other things that control what's done on a site is council zoning. So councils have the ability to apply a zoning to every property. That zoning, so we typically have residential zone, industrial zone, rural zonings such as watershed protection. We have things like hill space zoning as well. They control what form of development happens on those allotments to ensure that we have a more of a harmonious development of our greater urban area, that industrial areas are kept to one area, that shopping precincts in another, and that residential areas are another. However, you do have mixed use zones as well, so typical places for that are in inner city areas and places like Mawson Lakes. So one of the intents of a fair portion of Mawson Lakes was as this multifunction polis, where you can have mixed use zoning. So it's basically council's tool to influence and control what goes where. Also, another thing that may drive some of the decisions on site are the services available. So one of the first things we do when we're assessing a site is we locate existing services. So not only identify which services are on site, but it can also be very important, very handy to actually find out whether we have any services running underneath that site. So locate existing services such as mains gas, sewer, telephone, underground power, stormwater, grey water. we'll definitely want to be finding things like gas and underground power before we go doing any soil samples. If there's risk of underground services running across the subject property. So this here is a copy of a certificate of title. So the one to the left is the old paper form of certificate of title, and the one to the right here is the new digital form of the certificate of title. Typically, we won't get to see paper forms of certificates of title today, and if we order a certificate of title from the Lands Titles Office, we'll get sent out a PDF of a document that looks much like this. So the first page, and then the second page will be an extract from a survey plan image like this. So this is an entire survey plan image. So this is deposited plan 11-1206. You have both deposited plans and filed plans. What gives rise to either deposited or filed, I don't know. Basically, they serve the same purpose in that they show accurate survey records of the boundaries of properties and show us all the angles and lengths of allotment boundaries, plus things such as easements. So here, down the bottom here, we have a detail of easement A. Easement A is located on allotment 63 and 64. So if I have a quick look through there, let's see if we can okay, 63 and 64 allotment there at the end of Rose Crescent. We have an easement on the boundary of that. So that appears to be something in the order of electrical easement or an easement for drainage. Here's another survey plan image akin to what you would see attached to a certificate of title, showing two separate allotments, once again showing all of the information in regards to boundaries, and also bounding deposited plans. So we see we've got deposit plan 13246 here and 13438 over here. They may be important deposit plans also to audit if there are, if we can get some idea of any easements exist or encroachments and things from this area here if we're working on either of these two allotments. But the other thing to note here is that we can see that there's public road reserve bounding the property to the northern side or the northeastern side, and then we have two public roads coming there, so Northeast Road and Range Road South. So for anybody who knows their hills fairly well, they'll probably pick this one as being up, what is it, Houghton, I think it is. So right up the top of Northeast Road, just before you come into the township of Houghton. But there we have an easement running across there, easement A. That easement is actually for water supply. I've seen that property personally myself before, but just by looking at the title diagram here, or the survey plan image, that could be also for electricity, being 5.26 metres wide. That's fairly typical sort of width for an electricity easement as well. So more survey plan images. This is an older survey plan image, so hand-drawn survey plan image. So I mentioned before that we want to find services on site before we go doing any boreholes or soil samples. That's also one of the preliminary investigations that you carry out to determine what is the nature of the soil. Does it have good bearing capacity? So typically our footings need to be founded upon either 150 kPa or 50 kPa soils, depending on the type of footings required, and that's all detailed in the National Construction Code under, I think, Site Works. So we need to find out what is the bearing capacity of that soil. Also, we need to find out what is the reactivity of the soil. So within South Australia, we have highly reactive deep-seated clays. That means that we can have expansion from those clays for anything up to about 4 metres in depth. So we need to take samples, so core samples through the soil to around that 4 meters deep to see what the extent of any clays are, or any other soils or pockets of material that may be problematic. That will then be classed by an engineer, and the engineer will determine what is that soil classification. So they'll look at the soil and find various different horizons in that soil, and mention what their components of those horizons are, and then how deep each of those horizons of soil are. And with that, they'll attribute a total Y value to that soil. So that Y value represents a measure in millimeters of how much movement could be expected of expansion and contraction of that soil in extreme situations. So complete saturation to complete drying. Those Y values. So typically we've got they will tell you what soil classification you are, and our soil classifications are A for most stable sites, S for sandy soils, class M for fairly standard or sort of moderate reactivity, H for highly reactive, or we've got H1 and H2, so highly reactive, and even more highly reactive soils for H2. And then E for extremely reactive soils, so soils that have Y values over 100 millimeters. So the engineer will determine, okay, what are the Y values, what is the soil classification, and then actually there's one more classification I've neglected to mention, which is P-class soils. So P-class soils basically stands for problematic, so that can include basically any sort of problem, whether there's been previous excavation, unknown fill provided on the site, etc. So they're P-class soils, and they require individual assessment by the engineer as to how they're dealt with. So we take those soil samples, and the engineer will carry out the bore logs and attribute a classification to the soil, and that's going to be used for designing the footings. So that dictates, or the way the soil will react or bear load dictates how the footings will be designed. Initially, we need to carry out a site inspection, and before we carry out a site inspection, because it's time consuming, and obviously then in time is money, gets quite expensive. We want to minimise the amount of time that we have to spend on site, or minimise the number of times we have to visit a site as well. So it's important to have a checklist prepared before the site inspection. Features on the site that you may want to have a look at is look for any significant trees. So significant trees are, well, we've got both significant and regulated trees. Both of those trees have restrictions around what can be done with them and what can be done within the region of the tree. So we've got an Australian standard for protection of trees during construction, which defines the structural root zone. So structural root zone is if you disturb those roots, then the tree is at risk of falling over. And so SRZ and TPZ, which is tree protection zone, which is more about protecting the roots overall. And those SRZs and TPZ can be encroached upon. But that's all defined in the Australian standard for protection of trees during construction. So we'll want to have a look at any significant trees. That may dictate what we do and what we can do on site, or it may mean that it's required to remove trees from time to time. We want to know whether there's main sewer, because if there's not main sewer, then that has significant ramifications as to how we deal with our on-site wastewater system, and that's relatively restrictive in terms of requiring a decent amount of surface area or soil depth for dosing of that wastewater. So we're dealing with the wastewater in a hygienic fashion. We want to have a look at what fencing is there and what fencing needs to be put in put in place or taken down to allow access to the site. We want to see what other buildings and other structures there are, or other previous structures. Are there any remnants of footings and things like that that need to be removed? Certainly, if there's any location of any rivers or creeks, and potholes and mounds. While you're on site, you'll typically carry out or start the process of creating a contour plan, which is where you take spot levels on a grid pattern on the site, and then that is later translated into providing contours that show the topography of the land. And then that contour plan is used to determine finished floor levels, etc., and bench levels. So where you're cutting the soil to, and where your floor is, to what extent your floor is going to be on that site, which will also tell you what height any retaining walls need to be. So here are some images of contour plans showing basically, yes, the contours of those on that allotment. You also have to start thinking about site access, so material deliveries and trade access. That will dictate what materials are used on the site, because some materials are really quite large, or in the material timber, you can carry pieces in individually for erection on site, or you may want to save time on site by using prefabricated elements such as trusses. These decisions are dictated essentially by, or at times by, access and by budget. You have to think about storage on the site. Where can things be stored? Where can you place temporary toilets and other temporary structures and features? Also have a look, once again, for existing features, whether you need to demolish or remove anything, or tree removal, plant removal, etc. You'll want to maintain or inspect thoroughly any adjoining properties and maintain records on that, and consider those if you're having to excavate close to a boundary, what the impacts of the excavation close to the boundary will have on the adjoining property, such as support for footings. So there are regulations around this stipulated in the development plan, but also that can be read in conjunction with the sections in the National Construction Code that relate to site works, and soil types and the angle of repose for those soils. So for firm clay, which takes up most of Adelaide, we have an angle of repose of 1:1. That means if we cut down 1 metre, we have to be set 1 metre away from any low-bearing element, or we create a batter at 45 degrees. So the soil type will dictate that slope relationship. And then we record what services are on site, whether we already have a water meter or whether we need to pay for one, whether there's sewer, telephone, power lines, gas, grey water, stormwater, etc. So you can break your design principles down into primarily four main categories. So building design. So what sort of shape, what accommodation are you going to be providing by that building, and what external aesthetic and form is it going to take? What sort of materials are you going to take? Typically, we're looking at these two things in concert, because a type of material works typically in harmony with a shape of building, or it creates reference to a particular aesthetic. We need to think about energy efficiency of both the dwelling, so how that dwelling performs and how that responds to the site and the climate, and then any appliances, so any services in that building and how they impact upon the energy efficiency of that building. And also we need to understand what the occupant's behaviour is going to be like. So that's one of the first things that you do with your clients is get to know them, get to understand how they live, get to understand what they really require in a building. Building design must comply with the with building regulations, so the National Construction Code and the reference to Australian standards. Beyond that, there are also Minister's specifications that are referred to as well. So we have the NCC, we have the reference to Australian standards referenced within the National Construction Code, and then on top of that we also have some handbooks which are referenced and Minister's specifications. So they're state specifications or state minister specifications, and they are state specific. Must achieve a 6-star energy rating. So energy ratings are determined by computer programs. You can also, in complying with the National Construction Code, there are two avenues for that. You can take the deemed to satisfy, which is where you follow through the steps, basically the recipe as set out by the NCC and Australian standards, or you can determine a performance solution by engaging an engineer who is certified in that particular field. So energy efficiency, it's impacted significantly by the siting of the dwelling and the orientation of that dwelling. So we want, for good, passive solar design, we want our living areas to be facing north and our bedrooms to be facing south. This gives us cooler rooms for sleeping in, but warmer living areas in winter, and then well-maintained, cool living areas throughout the summer. So, in conjunction with the location of our living areas to the north, we want to maximise our windows to the north as well. And then reduce our windows to the east, south, east and west. It can be good to have a patio or courtyard to the northern side, particularly with deciduous vegetation that will drop its leaves in wintertime and allow sun through, but keep areas shaded in the summer. The use of that free solar radiation as the sun is low in the sky during wintertime can be soaked up by, if you have a concrete slab on the ground, so we have the sun shining on that concrete slab inside the house, that warms up during the day and then gives the heat off during the night. So that's what's referred to as thermal mass. We can also get some free air conditioning and cooling of the house by providing cross-flow ventilation. So that's ensuring that if we have windows either end of a building or either side of a building that can be opened up and let air to pass through and suck warm air out of the house. Works particularly well in a place like Adelaide, where we get cooling breezes in the evening from the southwest. Also, we want to ensure that the building is well insulated, so that climate that we are managing or creating by good orientation and windows is maintained within the house. So insulation stops the passage or restricts the passage of heat through the building fabric. Also, in Australia, we want to have light-coloured roof and walls. So in cooler climates, we may want to have darker colours where heating a building and getting the heat in there is more of an issue. However, because light colours reflect solar radiation and reflect heat, we typically want those lighter colours on all reflective surfaces on buildings. However, there are some restrictions on reflective surfaces in places like hill space zones, etc. So here's a diagram of solar access showing a garage to the western side. So the garage can cop that evening sun. That's fine in summertime. Our bedrooms are on the southern side of the house, keeping cooler, and our living room and kitchen is on the northern side. Oh, excuse me. And this is a cross-section showing the different sun angles during summertime. So in summertime, in Adelaide, we've got our sun rising almost due east, rising very high in the sky and setting almost due west. In wintertime, it rises more northeast and sets in a northwesterly fashion, and the sun angles sort of around that 34 degrees or so at midday, winter solstice. So it's actually quite low in the sky and can pour straight through the windows. Whereas in summertime, if you have adequate shading on the northern side of the house, the summer sun, which is quite high in the sky, won't reach the windows. So that was that passive solar design in a nutshell. Now there are some rules of thumb that can be applied. So this first image here shows that relationship between the eaves width and the height and placement of windows in relation to our solar angles for summer and winter, and then anywhere in between. So this portion under your eaves, to the head height of your window, so 30% of the total height of your sill to the underside of your eave, and then your eaves width should be 45% of that distance from underside of your eave to the sill height for latitudes such as Adelaide, so anything south of Brisbane. So diagrammatic representations of cross-flow ventilation, and also convection. So as air heats up, it rises and it's replaced by cooler air. This can be used to our advantage by having vents, operable vents high in the building that enable the passage of the hot air to go out, which will bring cooler air in if we provide other sources for cooler air. And that goes to the discussion around planting around buildings. So plants, basically, because they pull water out of the soil and evaporate that through their leaves, they work like a evaporative air conditioning system that's for free. So we can have plantings around our house, cooling the breezes that come through and providing a cooling effect on the house. Also, we can use those plantings for shade, and if we have deciduous trees, that's trees which lose their leaves in wintertime, we can enable more sun into areas during wintertime and then block that sun or provide that shade during summertime. We can also maximise our solar access and ventilation for various different scenarios. So here's a house with a very sloped roof with an open eave and lots of glass, enabling lots of light to get in there during wintertime, as with this house as well. So designed to maximise that the passive solar aspects of the building. How we build will also be dictated by the climate zone in which we are. So this is a map of the Greater Metropolitan Adelaide, and this is a map of South Australia showing the climate zones as they are for the National Construction Code. What we'll primarily be dealing with are areas within the metropolitan area here, which is Climate Zone 5, being mild temperate, and then Climate Zone 6, which takes in much of the Fleurieu Peninsula, Kangaroo Island, and the southeast down to Millicent and Mount Gambier, etc. And then some areas up through the Barossa and into the mid-north, so Clare Valley. I'm not sure if that's quite. Well, it's touching on the Flinders, but probably not up as far as Hawker or so. So that's Climate Zone 6, which experiences colder nights, where we've got more requirements for insulation. This picture up here, this is Coober Pedy. So for anybody who's visited Coober Pedy, you'd understand that it does get very hot up there during the day, so very little vegetation and shading, and extremely cold nights. And so there it's beneficial for people to build houses underground, and also the soil conditions are conducive to that. Also, we have to think about the thermal performance of the building. So once we know that climate zone and we know what we want to be dealing with, we have to think about getting that solar access, and also utilising that solar access via via the incorporation of thermal mass. One way of doing that is to include a reverse brick veneer wall, which is where you've got a wall that has actually the bricks or concrete on the inside of the wall to provide additional thermal mass inside the house, and then we have a layer of insulation, lightweight framing, and then lightweight cladding on the outside to insulate this thermal mass, keep that locked in the house. So if we manage our temperatures well in the house, well then that thermal mass can be of a benefit. Where thermal mass can be a curse is where you have little control over the passage of heat and cool into your house, and then you have a really long hot spell. All this thermal mass heats up and keeps giving out heat throughout the night when you don't want it. I'll just pause this for a minute. Rightio, get back. Yeah, apologise about that break in proceedings there. So now, yeah, back to thermal performance for dwellings. So we're speaking about the utilisation of that thermal mass when you've got your orientation and your solar access and cross-floor ventilation. Good thermal mass can certainly be of a significant benefit to you. On the right hand side of the slide here, we've got a table that shows the thermal mass of different materials, and that's per cubic meter. It's important to how to say it, to understand that, particularly if we're talking something like fibre cement sheet. So fibre cement sheet certainly has a very large thermal mass in regards to its cubic meterage, but because we use fibre cement sheet in 6mm and 9mm layers, it's typically we don't get a great deal of thermal mass out of that product. Whereas if we're using concrete or sandstone rammed earth, we've got significantly thick walls, a lot of cubic meterages used, and significant contribution to thermal mass building. Also, insulation. So insulation both helps a well-designed building and it helps a poorly designed building as well. It helps control the passage of heat flows from inside to outside. Various different forms of insulation. This insulation on the top left-hand corner, this is a requirement for steel-framed houses, so to stop the thermal bridging. It's installed much like your builder's wrap or sarking, but it also has these little air cells in between it that stops, that impedes the thermal bridge between your purlins and your sheet roofing, and also your steel wall frames. Over here on the bottom left-hand side, we've got batts, and those batts are probably your most typical form of insulation, or your cheaper form of insulation. So they're just put into the walls or the roof. Those batts, to work effectively, they can't be squashed. They do need to have proper loft, is what it's called, when they're allowed to maintain their full size. That's when they work to their designed efficiency. And then things like bulk insulation, which is pumped in, such as your Cool or Cozy recycled paper insulation. And one thing we don't have a picture of here is your firm board type insulation, like the PIR, foam, etc. So this is a quick summary of the insulation that is required around a house in the location. So for walls and roof. And here's a quick summary of glazing required. So about how much glazing you want to the various different elevations of your building. Now, obviously, this is purely keeping in mind passive solar design. It doesn't take into consideration views and things like that. So you've got to balance all those considerations of your client. And also, it's not taking into consideration cross-flow ventilation or any other particular features you may or may not want to look at from the dwelling, or even sources of noise such as road noise. So So windows will allow the passage of road noise much more than a solid wall or even a lightweight framing wall. However, your glazing options can deal with that as well. If you've got double glazing, that's very good for reducing road noise. But anyhow, back to this table. So you want around the 60% facing north, 30% facing south. The south-facing windows don't help us in a passive solar sense. However, they do provide light to the southern side of the building, so we end up using less electricity in terms of having to put lights on all the time and increase that amenity of the building. You want only about 15% on the eastern side and 0 to 7% on the western side. So this is as a general guide to the percentages of glazing you want in each elevation. Beyond that, there are some useful websites you can have a look at. So this one right down the bottom, yourhome.gov.au, is an excellent website for a lot of considerations building. I highly recommend you go to this website and have a good work through if you're not already familiar with it. It's excellent introduction to building and building design. And then we've got Planning SA Home, so that's where all the development plans are located, and also a website called sustainableenergysa.gov.au in regards to providing you with information about sustainable energy in buildings. So that's the end of this session today. I'll be getting on hopefully with the next session, probably a bit out of cycle, a bit earlier, so we can really start progressing into actually looking at the properties of various different materials and applications of materials fairly early to enable you to get researching and to get stuck into your assessment tasks there. And as always, if there are any questions or queries, please don't hesitate to contact me via email, michael.jenkins@tafersa.edu.au. Thank you.